In this lecture, I am going to present what is statically determinate and indeterminate structure, and how to find out the static indeterminacy of pin jointed plane frame and pin jointed space frame by using two approaches. First, we have to know what is statically determinate and what is statically indeterminate structures. When the number of independent equilibrium equations is equal to the number of independent direction components, the structure is called statically determinate structure. Because all the unknown direction components in these structures can be determined from the equation of equilibrium alone. And when the number of independent direction component is greater than the number of independent equilibrium equation, in this case the equilibrium equations are not sufficient for the determination of unknown direction components. So these structures is called statically indeterminate structure or hyperstatic structure or redundant structures. These structures may be analyzed by writing additional equations of compatibility of deformation. Generally, a structure may be externally indeterminate or internally indeterminate. A structure is said to be externally indeterminate if the available equations of equilibrium are not sufficient to determine the external direction components. And internally indeterminate occurs when the internal forces or resultant stress cannot be determined from the available equations of equilibrium. Generally, a truss consists of two types. One is plane truss and another one is space truss. Plane truss is generally known as pin jointed plane frame, and the space truss is generally known as pin jointed space frame. Or the plane truss is also called the 2D truss, and the space truss is also called the 3D truss. Then what is static indeterminacy? The number of equation of equilibrium falls shorter than the number of unknown direction components is known as the degree of static indeterminacy or redundancy, or the number of compatibility equation that is equal to the degree of static indeterminacy or redundancy. There are two different approaches may be used for the determination of degree of static indeterminacy. Then coming to the first approach. So in this approach, the total degree of static indeterminacy is equal to the sum of degree of external static indeterminacy and internal static indeterminacy. The degree of static external indeterminacy can be denoted by D subscript SC, and the degree of static internal indeterminacy can be denoted by D subscript SI. Then the total degree of static indeterminacy can be determined by taking the summation of degree of static external indeterminacy and degree of static internal indeterminacy. And the degree of static indeterminacy can be denoted by ds is equal to dsc plus dsi. Then coming to the external indeterminacy. The external indeterminacy is related to the support system of the structure. If the number of independent reaction components is more than the available equations, the structure is externally indeterminate. The degree of static external indeterminacy for plane structure can be determined by dsc is equal to r minus 3, where r is the number of reaction components and 3 is the number of available equations for plane structure. Similarly, the degree of static external indeterminacy for space structure can be determined by dsc is equal to r minus 6, so where r is the number of reaction components and 6 is the number of equations available for space structure. Then coming to the internal indeterminacy. So first we will discuss how to find out the internal indeterminacy of pin-jointed plane frame, or this is also called the 2D truss or plane truss. So here this is the simple plane truss having 3 joints and 3 members. Then 2 more members are required for connecting each additional joint to the triangular frame already formed. So J is the total number of joints in a pin jointed plane frame, and the total number of members required to connect the remaining J minus 3 joints is equal to 2 into J minus 3. So here for this additional joint 2 members are required. The simplest plane frame is the triangle, 3 joints and 3 members, and here for extra joint, so here need 2 more members. So the number of members required to connect the remaining J minus 3 joint is equal to 2J minus 3. Then the total number of members in a pin jointed plane frame is equal to M dash. M dash is equal to 2 into J minus 3. This is the member required for the additional joint, plus this is the 3 the members which is required for the simplest frame. This is the member which is required for the simple plane frame, and this is the member which is required for the additional joint. So M dash is equal to 2 into J minus 3 plus 3. So this is equal to 2J minus 3. Then after simplification, M dash is equal to 2J minus 3. So if M dash is equal to 2J minus 3, then this is the determinate structure. The total number of members required in a pin jointed plane frame with J joint is equal to M dash is equal to 2J minus 3. A pin jointed plane frame is statically indeterminate internally if the number of members is more than 2J minus 3. If M is greater than 2J minus 3, then this is called the statically indeterminate internally. If M is less than 2J minus 3, then this type of frame is internally unstable or deficient frame. If M is less than 2J minus 3, if the number of members is less than 2J minus 3, the frame is internally unstable or deficient. The degree of static internal indeterminacy of pin jointed plane frame can be found out. The difference between these two, M dash and 2J minus 3, and this gives the degree of static internal indeterminacy of pin jointed plane frame. So DSI is equal to M minus 2J minus 3. Then coming to the pin jointed space frame or 3D truss, or this is also called the space truss. So in the case of pin jointed space frame, the most elementary frame is a tetrahedron. So in the tetrahedron, there are having 4 joints and 6 members, 1, 2, 3, 4, 5, 6. So besides 3 additional members is required to connect each additional joint. So for each additional joint, 3 additional members are required. 1, 2, 3, 3 additional members required for each additional joint. So the total number of members required in a pin jointed space frame with a J joint is equal to M dash is equal to 3J minus 4 plus 6. So this is the member required for the additional joint, and this is the preliminary members which is required for the tetrahedron. This is the preliminary members which is required for the tetrahedron. This is equal to 6, and this is the members which is required for each additional joint. So M dash is equal to 3J minus 4 plus 6. So this is equal to 3J minus 6. The total number of members required in a pin jointed space frame with a J joint is equal to M dash is equal to 3J minus 6. So this is a determinant. If M dash is equal to 3J minus 6, this is determinate structure. if the number of members is greater than 3j minus 6, if m is greater than 3j minus 6, then the pin-jointed space frame is called the statically indeterminate internally. A pin-jointed space frame is statically indeterminate internally if the number of members is more than 3j minus 6. M is greater than 3j minus 6. If the number of members is less than 3j minus 6, the frame is internally unstable or deficient structure. M is less than 3j minus 6. The degree of static internal indeterminacy of pin-jointed space frame can be found out using this equation. DSI is equal to M minus 3j minus 6. So this is the summary degree of static internal indeterminacy of pin-jointed plane frame can be find out using this equation. DSI is equal to M minus 2j minus 3, and this is the degree of static internal indeterminacy of pin-jointed space frame, and this you can find out using this equation. DSI is equal to M minus 3j minus 6, and the degree of static external indeterminacy of plane frame. So DSC is equal to R minus 3. Similarly, the degree of static external indeterminacy of space frame, DSC is equal to R minus 6. Then finally you can find out what is the degree of static indeterminacy using this formula. DSC is equal to DSC plus DSI. Then coming to the second approach, first we will discuss for the pin-jointed plane frame or plane truss or 2D truss. In the case of pin-jointed plane frame, loaded in its own plane, each member carries only one internal reaction component, that is axial force. Each member carry only axial force. So in this case, the total number of reaction components can be found out, that is the external reaction components plus internal reaction components. So the external reaction components can be found out from the support system, and the internal reaction components can be found out from the members, number of members. So the total number of reaction components is equal to R plus N. At each joint, there are two equations of equilibrium, that is summation of Fx is equal to 0 and summation of Fy is equal to 0. So the total number of independent equations of equilibrium is equal to 2j. Then you can find out the degree of static indeterminacy by taking the total number of reaction components minus the total number of independent equations of equilibrium. So the total number of reaction component is equal to R plus M, and the total number of independent equilibrium equation is equal to 2j. So degree of static indeterminacy is equal to ds is equal to M plus R minus 2j. So using this formula also you can find out what is the degree of static indeterminacy of pin-jointed plane frame or plane truss. Then coming to the pin-jointed space frame or space truss or 3D truss, how to find out the degree of static indeterminacy using the second approach. So in the case of pin-jointed space frame, each member carry only one internal reaction components, that is axial force. Each member carry only axial force. Then the total number of reaction components can be found out, that is from the external reaction component, from the internal reaction components. So the external reaction component can be found out from the support system, and the internal reaction component can be found out from the members. So the total number of reaction components is equal to R plus M. Then at each joint there are three equations of equilibrium, that is summation of Fx is equal to 0, summation of Fy is equal to 0, and summation of Fz is equal to 0. So the total number of independent equations of equilibrium is equal to 3j. Then you can find out what is the degree of static indeterminacy. So that is equal to the total number of reaction components minus the total number of independent equations of equilibrium. So DSC is equal to M plus R minus 3j. M plus R is the total number of reaction components, and 3j is the total number of independent equations of equilibrium. So this difference is the degree of static indeterminacy of pin-jointed space frame or space truss. Now all are clear. So how to find out the degree of static indeterminacy of pin jointed frame, that is truss.